So to continue systems, we're solving systems algebraically today. You guys yesterday did them graphically, and most of them worked out pretty darn well. Now, in your work together that you went through, hopefully you found, looking at this, okay, number one, use the graph to estimate a solution to the system at the right. A little tougher, right? Why is that so difficult to figure out the solution to that system? Okay.
Because it's like not directly on a point.
Good. It's not directly on a point. It doesn't cross a grid perfectly, and most of your systems won't. All right? So you could estimate it. You could check your estimate. All right? But rather than doing it that way and kind of estimating using the graph, plus it takes a long time to graph, what we do is we solve algebraically. So there's two ways to solve systems algebraically. Okay? What are the two ways? Parker, what's one of them? Substitution. So let's start out by doing substitution. We're going to work through a couple problems together. Many of you may feel very comfortable with it already, but this is off the example side of your worksheet. Okay? We're going to do 1, 2, and 3 to start out, at least 1 and 2. Okay? So I want you to try in your notes solve number 1 using substitution. I need someone to tell me what makes this problem lend itself, why does this problem lend itself really well to substitution? Connor?
Because you already have one of like the variables. Because it's y equals x plus 1.
Good.
So you add it to the...
All right, so you have a variable alone already. We already know what y equals. They're telling us y equals this. If they ever tell you, if you're given two equations, first, if you have an x and a y, if you have two variables, you need two variables to, or you need two equations to solve. So that may seem obvious to you, but let's go back and recap some algebra. If you have one variable, to solve for that variable, you need at least one equation. If you have two variables, to solve for those two variables, you need at least two equations. If you have three variables, Austin, how many do I need? No. Three what? Good. If I have three variables, I need three equations. If I have four variables, I need four equations. Now, that's a pretty general rule. All right? Now, you may have already thought of that. You're like, okay, yeah, I get that. You may never have thought of it, but now it may make sense. Okay? Since I have two variables, a y and x, I need two equations to solve for those two variables. This one tells me y equals this. That means in this equation, I know that another name for y is x plus 1. Or in this system, another name for y is x plus 1. All I need to do is plug that into y in the other equation. Okay? So now we have 2x, and when we substitute in, you need to get in the habit of substituting using parentheses. Okay? May seem like a waste of time many of the times for you, but as you progress in math, it won't seem like a waste of time. So this becomes 3x equals 6. So subtracting 1, and then x equals 2 because we divide each side by 3. X is 2. Now, we want an ordered pair, right? We know x is 2. We need to still solve for y. You need to substitute that back into one of your original equations. So if I put it, say, into this one, since y is already by itself, y equals 2 now plus 1. We put the 2 in for the x. So that means y equals 3. The ordered pair 2, 3. Okay. Chloe.
I know how to do it.
Thank you. All right.
No, like I know how to do the other one too.
All right, good. So what do I do on the other one?
You have to plug in, so for in the second equation, you would go, because you know what x equals, so you go 3, and then parentheses y minus 2 minus y equals 6.
Good. And so this is where the parentheses really make sense. Nice work there. Okay, parentheses are a big deal right here. So as Chloe said, put it in parentheses. So we have 3y minus 6 minus y equals 6. So simplifying each side of the equation first, this becomes
2y minus 6.
2y minus 6, 3y minus y. So remember, as you're reading, the symbol that goes in with the variable is the negative symbol there. So 2y minus 6 equals 6. 2y equals
12.
12. Good. You're adding 6 to both sides. I don't need to see that step in between. Y equals 6. Okay? I need to see a trail of your work. I don't need to see like the plus 6 on both sides. But I do want to see your new line each time as you're going through it. Okay? Put the 6 back in for the y. X equals 6 minus 2, or x equals 4.
Wait, for like the division steps, do you want us to show that? Like,
For the division, like here,
yeah, do you want us to like?
I don't need to see it.
Okay.
I just need to see
The
each new line.
progression.
Yep.
Can we do it in our head, or is that not allowed
No.
anymore?
Hey, good question, guys. If you come in tomorrow, okay, too much talking going on. If you come in tomorrow and you just have answers on your paper, don't even bother turning it in. Okay, you have to show your work. I need to see the progression at least. It's a good way of putting it, Jaden. Need to see the progression. I don't need to see the plus 6 on both sides, but I need to see a trail. All right? All right, so in this one right here, okay, I throw this in for
Or y, yeah.
y. Okay? Now the reason I'm doing this is because, like, I think you guys get it from some of the participation. There's a common mistake that's made on this one. So everyone needs to complete number 3 there, just to make sure we don't make that mistake. Okay, let's see how we did here. When I put that in, I have 5x minus 2x plus 3 equals negative 3. Now notice when I put that in, I put those parentheses in. This is like having a negative 1 hanging out here. So for those of you who didn't catch that, this actually becomes 5x minus 2x, which that's not where the mistake is made. It's usually made right here.
Oh, I did.
Negative 1 times 3 is negative 3.
Oops.
Okay, so if you put plus 3 back there, that's a common error. You are a common advanced math student. Good job. Okay, that's okay. 5x minus 2x is 3x minus 3. Add 3, 3x equals 0, so x is 0.
I totally got that.
If x is 0, we have y equals 2 times 0 plus 3, or y equals 3.
I wrote it down in the common error, but I didn't.
It
Like-
fixed itself somewhere in there. You made
Yeah.
another mistake to fix it. That happens sometimes. Okay,
I had a plus sign here, and then I got to 3x.
any questions on substitution?
I don't know how I did that.
Substitution's really great if one of the variables is already by itself. Okay? Tell your neighbor what the other process is.
Elimination.
Okay, so we have graphing, which takes a while. We have substitution. We have elimination. Okay? Tell your neighbor why number 12 lends itself very well to elimination.
Because
Okay,
then.
give number 12 a shot. Even if you're not quite sure what to do, give it a shot. See what you can remember.
I think you.
Thank you. All eyes back up here. So elimination is also sometimes called the subtraction method. I never subtract my equations. I add, just because if your brain works a little better, I tend to think in addition. So really what I'm looking for are opposites. Okay, I'd like to be in standard form, which I am. I have my x's and y's, or at least have the x's and y's on the same side. Okay, so that's set up well for elimination. These are the same. These are opposites, right? This is a positive y, and that's a negative y. When you have opposites, it works out really well. X plus x is 2x. Positive y and negative y is 0. That's gone. I've eliminated that.
That's
Okay?
why it's
I've
called-
terminated it, right? It'd be cool if it was called the termination method. Or
Dude, that'd
Terminator.
be so cool.
You'd be terminators then? That'd be awesome.
Terminators.
Okay,
That's
maybe not
awesome.
so awesome. X is
6.
6. Okay? So it sets up really well. It just eliminates. X is 6. Okay, one of our solutions, we plug that back into one of our equations. So this one would work. X plus y equals 10. So y then is 4. So we have y is 4, x is 6. The ordered pair 6, 4. Good buddy. Okay. Now, I realize that when you were in algebra, some of your algebra teachers told you to subtract. And I think you make more mistakes subtracting like that. I'm not saying anything is wrong with what your algebra teacher taught you, but I personally think addition's better. I think it works easier, and you make less mistakes. If you're used to subtracting, you feel very, very comfortable with it, and you never make mistakes, then use it. That's up to you. But there becomes a lot of flipping of signs and stuff when you have to subtract. Just makes it easier if you set it up for addition. Okay? 6-4, good buddy. Any questions there?
Oh wait.
Yeah.
So like, say like number 14, how the variables like x and y both stay there.
Mhm.
How would
Well,
would
why
you
don't
s-
we let's get to one of those here in a minute, okay?
Okay.
Hey, you guys, the other thing is I get some students that are very elitist in terms of their methods. They're like, dude, I don't use elimination. I'm a substitutionist. And then there's
Yes.
others that are like, I don't substitute, I'm an eliminationist. Okay? And I don't have too many graphists, okay, that want to just graph. I have some calculites that just want to calculate using their calculator.
Hey man, yeah. So
Now, I will tell you, calculites don't work all that well all the time because eventually I don't let you use calculators. And when you have systems of 3 variables and we're solving them by hand, that's very difficult trying to use your calculator to see where they cross because you're graphing planes. Okay? So if you're like a graphite and you like using the calculator to graph them and see it, okay, the calculites are really nice when you use matrices, but once again, I don't always let you use them, so you have to learn them by hand. So if we eliminate that to be an eliminite or eliminist or a substitutist, I would suggest you learn both methods. It makes your life a lot easier. And then apply the one that's the most valuable, okay, for that situation. In number 4, this is on the mixed side. So you might want to label that in your notes. This is mixed number 4. On number 4, I want you to use elimination there. Work with your groupies. You get about a minute to figure out how you're going to eliminate something.
divided by.
Okay,
divided by
wrap it up, please.
It's 3. Y x is equal to 3. And you substitute that in.
All right.
And
Have
y
your
is equal
attention
to
back
0.
up here. I'm going to call these equations by letters. I'm going to call this equation A and this one equation B. Now, really, that's setting you up for systems of 3 variable equations when we do that because we call them A, B, and C, but A and B. If you didn't do that, that's fine, but it'll help me out a bit here. How am I going to solve, or how am I going to eliminate something here? A couple of us. Lily, what do you think?
You have to multiply it, so then, like, you could have the y's with x's, but since it's easier to do the y's so that the numbers equal each other.
Okay, so you're going to multiply. You say it's easier to do the y's. One thing that makes it a little easier for the y's is that they're already opposites.
Yeah.
Okay, so what are you going to multiply by?
I multiplied a by, 5 and then b by 4.
So you're multiplying 5a times 4b. Everyone agree with that?
Yep.
Okay, so equation A, I'm multiplying by 5. That gives me 15x. It gives me 5 times 4 is negative 12y. No? Oh, 20y. Thank you.
You're welcome.
Okay, negative 20y, and then 5 times 9 is 45. Okay, so I've got that, and then 4b is 4 times 2 is 8x. 4 times 5 is 20b, or 20y, excuse me, and 4 times 6 is 24. Does everyone see how the x's and y's help me a bit, or the a's and b's help?
Yes, sir.
They kind of just leave your road markers. Now, you don't have to do that if you don't want to. You could just show it right out here. You could say times 5 and times 4. But I want you to be able to figure out what you did if you're looking back at your work. And that's what this is for. Okay? So now we eliminate here, right? There's my 0. 23x equals 69. X equals 3. If x is 3, I've got to plug that back in somewhere up there. Maybe I use A. Okay? If I use equation A, that's 3 times 3 minus 4 times y equals 9. 9 minus 4y equals 9. Negative 4y equals 0, so y has to be 0. Ordered pair 3, 3, 0. Let's make that into a 0. 3, 0. Okay. Any questions on it? Leave a trail, please. All right, I'm almost out of time. However, I had 2 problems on the example side. I want you to solve both of those. You choose substitution or elimination. In fact, you don't have to solve them. I just want you to tell your neighbor which one you're going to use for each of them and why. To wrap up our discussion, how many say number 4, I am using substitution? Can someone tell me why substitution? Hannah, why?
Because you can easily subtract the 2x and that'll give you y equals negative 2x minus 1 and you can easily plug that into the first equation.
Okay, so one argument for substitution is just to solve this one for y. So I go y equals negative 2x minus 1, and there. I now could substitute that in for y up here. Okay, one argument for substitution. Any arguments for elimination?
Yeah.
Who said elimination? Okay, Madison, why?
Because you can already eliminate, you can eliminate y because equation A is negative and equation B is positive, and everything on you can just multiply it by 3.
Okay, so we got a positive negative y. Say I just want to multiply this one by 3, and that then gives me something that I can definitely eliminate with the y's. That gives me 6x plus 3y equals negative 3. Okay? Dylan?
Is there truly like a right way to do it, or can you do either or?
You could do either or. You should get the same answer. Now, is there another argument for elimination or substitution? Okay, let me show you what I would do on this one. Now, both of those ways are definitely valid, and it's up to you. How many of you tend to lean towards one way or the other? You're like, I know I'm biased towards this way. Okay, just out of curiosity, how many are biased towards elimination? How many are biased towards substitution? Okay, I'm just wondering. Now, if I was doing this problem quickly, the first thing I do, just like reducing fractions, you can reduce equations. I can factor a 3 out of this. That brings me down to
2x.
3x minus y, excuse me, thank you, 2x minus y equals negative 33. The benefit there,
No, negative 11.
negative 11, my goodness, thank you. The benefit there, the one thing that I actually wanted to have correct is the correct part. The benefit there is that's a negative y and that's a positive y. Okay? And which that just eliminates. And when I subtract, or excuse me, when I add there, I get 4x equals negative 12. And x is negative 3. I tend to lean towards elimination if I can. Now, there are times when elimination is not beneficial at all. Okay, but in this case, I think it's pretty beneficial, especially if you know how to reduce equations. Factor the same thing out of all terms. You don't ever have to bring it back in. It's just reducing that equation. Okay? How many have seen reducing equations before? Start trying to recognize that. It makes the math a lot easier. Okay, and then we'd have to solve for y, right? If we put negative 3 in, we get negative 6 plus y equals negative 1, or y equals 5. Okay, so negative 3 and 5. All right.
Hey man, that works.
Okay, how many say elimination here? Substitution. Okay, if you're using elimination, maybe you multiply the top one by what? How many are eliminating x? How many are eliminating y? What do you have to multiply by to make it a 2? Negative 2, which gives you positive 2. So I have to multiply this whole thing by negative 2. Okay? If you're using substitution, are you moving the 2x on this one? Or are you moving the y? Move the y over and then move the 7 over?
What's going on?
How many are using substitution on this one? Okay, how are we getting, what variable are we getting alone? Cool.
Y.
Getting y alone?
Mm-hmm.
So you're going to move the 2x over?
Yeah. Or, well, you can just add y and then subtract 7.
Okay, you could add y over and then subtract 7 over.
So just switch guys.
All right, I think we're pretty good on that. Okay, one problem, one story problem, and we're done. Okay, number 10.
Sweet, man. Cool beans.
There we go. Actually, let's do number 11. I like that one better.
Number 11?
Number 11, example side. Give it a shot. What are my variables on this? Jaden?
Well, I did X is the cost per performance.
Okay, so can I use C?
Or, yeah.
Makes it a little easier. So cost for performance. Okay, another variable, someone else. Cool.
I for the income for each sold out performance.
Okay. All right, income. All right, so suppose Drama Club is planning production. Their cost is $525 for the set, $150 for performance, sold out performance, bring in $325. Write an equation for the cost and an equation for the income. Find out how many sold out performances will make the cost equal to the income. So we want cost equal to income. Right?
Oh, yeah.
That's our kind of goal here. Cost equals income. Okay? What are all of our costs? Like, how do we come up with the total cost? Yeah.
You do 150p, which would be the performances plus 525 to 7.
Okay. So 525 is a one-time charge, right, for the set.
Right.
And then a reoccurring charge is the 150 per usually, that tells you a rate. It's a reoccurring thing per performance. Okay? So per, I guess we're saying C, the cost of a performance. Okay? Maybe we should have used P there. All right. Was that what you were going to say?
Say that you should use P and then wouldn't it equal C
Um,
for the total cost of
Yes.
performance?
Yeah, so if you're using P, yeah, if you look at it a different way, if you call this P, that's equal to C. Okay? So if we add another variable,
I just use X.
so this could be your total cost. All right. Is that what you use, Bella? Okay. All right. How about income? Yeah.
I equals 150p.
So
No longer 325p.
I equals 325p? Yeah. Bring in each performance 325p. All right? We want cost and income to be equal. So using this model here, if cost and income have to be equal, we want this to equal that. Right? It's a break-even point. Okay, when your cost is equal to your income, that means, have you made any money? No, I mean, but have you lost money? No, it's a break even. So 525 plus 150p equals 325p. So in other words, how many performances do you need to sell out in order to make it work out? Well, collect your p's on the same side, right? We get, add 150, so that is 475p. Or excuse me, subtract. Thank you. Gosh. All right.
I don't know what this. I don't know how this. Okay, just keep it.
175?
Oh,
I think.
I
Yeah.
thought you were talking to me there.
No.
Okay, 175, 525. So one performance is,
Somebody with the calculator.
divide there.
It's like
2.1.
or 3. No.
Yeah.
3.
Yeah, 175 and 175 is,
325 plus 175 is 500. Right?
Nope.
Wait, what? No.
350, I think.
Oh,
350 plus
okay.
another, yeah.
Okay.
Okay, so it looks like we need 3 performances. So if you do 4 performances, do you make money?
Yeah.
If you do 2 performances, do you make money?
No.
Okay. Your assignment is the mixed side, 1 through 15, as well as 26 and 27. 1 through 15 and 26 and 27. Okay? So cross out these here in the bottom. And then you can cross out all story problems with the exception of numbers 26 and 27. Okay? you can use whatever method you want. So if you lean towards a certain method, that's up to you. Okay. Show your work, please.